Chapter 5 Arithmetic Progression. Consider the natural numbers 1, 2, 3, 4, etc. in which the second number is getting by adding 1 to the previous number, third number is adding 1 to the previous number, like that. That means for each step we are adding 1. This is an example of an arithmetic progression. That means arithmetic progression is a list of numbers in which each term is obtained by adding a particular number to the previous number except the first number. In this series, each number is getting by adding 1 to the previous number except the first number. First number should be given. So, this kind of numbers or list of numbers are called arithmetic progression. So, arithmetic progression is a list of numbers in which each term is obtained by adding a particular number to the previous number. And this particular number is called the common difference. This particular number is called the common difference, which we can mark as CD. Then this arithmetic progression can be finite or infinite. If the number of terms are finite, it is finite AP, otherwise it is infinite AP. Let the first number be A. Let the first number be A and the common difference is D. Common difference is D. So, the arithmetic progression is first term A. Second term we are getting by adding D to A. Third term we are getting by adding D to A plus D. So, third one is A plus D plus D plus D, etc. So, the general form of an arithmetic progression is A plus D, A plus 2D, A plus 3D, etc. in which A is the first term and D is the common difference. This is the general form of an arithmetic progression. Just A plus D, A plus 2D, A plus 3D, etc. If A1, A2, A3, etc. are in AP, then we can find the common difference by A2 minus A1, which is also equal to A3 minus A2, which is equal to A4 minus A3, etc. So, what I said is arithmetic progression is a list of numbers in which each term is getting by adding a particular number to the previous number. So, this common difference, this number is called the common difference. This can be either positive, negative or 0. The common difference can be a positive number or a negative number or 0. So, next is exercise 5.1. Second question. Write the first 4 terms of the AP when the first term is A and the common difference D are given as follows. Write the first 4 terms. So, first term we can denote as A1, which is equal to A, which is equal to 10. Second term you can denote as A2, which is equal to A plus D, which is equal to 10 plus 10, which is equal to 20. Then A3 is equal to A plus 2D. A plus D plus D, that is A plus 2D. So which you can write as 10 plus 20, which is equal to 30. Then A4 is equal to A plus 3D, which is equal to 10 plus 30, which is equal to 40. So the AP is first term 10, second term 20, 30, 40, etc. So A is given as 10, D is given as 10. So first term is A itself 10, second term is A plus D 20, third term is A plus 2D 30, fourth term is A plus 3D, it is 40. So the required AP, you should write the final answer like this. AP is 10, 20, 30, 40, etc. Then it is given that same question, third subdivision, A is equal to 4 and D is equal to minus 3. So A1 is equal to A is equal to 4. A2 is equal to A plus D, which is equal to 4 minus 3, which is equal to 1. A3 is equal to A plus 2D, which is equal to 4 plus 2 into minus 3, which is equal to 4 minus 6, which is equal to minus 2. A4 is equal to A plus 3D, which is equal to 4 plus 3 into minus 3, which is equal to 4 minus 9, which is equal to minus 5. So the AP is, required AP is 4, 1, minus 2, minus 5, etc. So here the common difference is negative. Then third question. For the following APs, write the first term and the common difference. So in AP is given 3, 1, minus 1, minus 3. So we can take A1 as 3, A2 as 1, A3 as minus 1, A4 as minus 3. For the following APs, it is given that it is an AP. So you have to find the first term and the common difference. The first term, what is the first term? A is equal to A1, which is equal to 3. The common difference D is equal to A2 minus A1, which is equal to 1 minus 3, which is equal to minus 2. So the first term is 3 and the common difference is minus 2. Same question, an AP is given, you have to write the first term and the common difference. So A1 is equal to 1 by 3, A2 is equal to 5 by 3, A3 is equal to 9 by 3, etc. So the first term A is equal to 1 by 3 itself, and the common difference D is equal to A2 minus A1, which is equal to 5 by 3 minus 1 by 3, which is equal to 4 by 3. So final answer, A is equal to 1 by 3 and D is equal to 4 by 3. Then fourth question, which of the following are APs? If they form an AP, find the common difference D and write 3 more terms. Which of the following are APs? We have to check whether the given series is an AP or not. If it form an AP, you have to find the common difference D. After finding that, you have to find 3 more terms. So here what is given is A1 is equal to 2, A2 is equal to 4, A3 is equal to 8 and A4 is equal to 16 and so on. So first we have to check whether it form an AP. For that we have to find A2 minus A1. What you have to check is whether the common difference is same. If it is same, then it form an AP, otherwise no. So A2 minus A1 is equal to 4 minus 2. It is equal to 2. Then A3 minus A2 is equal to 8 minus 4, which is equal to 4. So the conclusion, from here itself we can conclude. So A2 minus A1 not equal to A3 minus A2. A2 minus A1 not equal to A3 minus A2. So the conclusion is it is not an AP. It is not an AP. The common difference is not same, so it is not an AP. Then fifth subdivision, same question. Here A1 is equal to 3, A2 is equal to 3 plus root 2, A3 is equal to 3 plus 2 root 2, A4 is equal to 3 plus 3 root 2. First we have to check whether it is an AP or not. For that we have to find D. So A2 minus A1 first, 3 plus root 2 minus 3, which is equal to root 2. And next one, A3 minus A2. So 3 plus 2 root 2 minus 3 plus root 2, which is equal to 3 plus 2 root 2 minus 3 minus root 2. So we can cancel off these two, remaining root 2 itself. And A4 minus A3 is equal to 3 plus 2 root 2 minus 3, A4 is 3 plus 3 root 2 minus A4 minus A3 is equal to 3 plus 3 root 2 minus 3 plus 2 root 2. So we can cancel these two, 3 root 2 minus 2 root 2, again root 2. So the conclusion is all these are equal, so it forms an AP. So what we can say is A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3. So it is an AP. So the question is, if it is an AP, you have to find 3 more terms, and this is equal to root 2. A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3 is equal to root 2. So it is an AP. So you have to find 3 more terms. A5 is equal to A4 plus D. What is A4? 3 plus 3 root 2 plus root 2, which is equal to 3 plus 4 root 2. Similarly, A6 is equal to 3 plus 5 root 2. A7 is equal to 3 plus 6 root 2. So write the final answer. The 3 more terms are 3 plus 4 root 2, 3 plus 5 root 2 and 3 plus 6 root 2. So same question, 11th subdivision, A square, A cube, A raised to 4, etc. First we have to check whether this is an AP or not. If it is an AP, you have to find 3 more terms. So A1 is equal to A, A2 is equal to A square, A3 is equal to A cube, A4 is equal to A raised to 4. So you have to find D first. A2 minus A1 is equal to A square minus A, which is equal to A into A minus 1. Next, A3 minus A2. A3 is A cube minus A square, which is equal to A square into A minus 1. Clearly, A2 minus A1 not equal to A3 minus A2. So, this is not an AP. Next question, 12th subdivision. So, root 2, root 8, root 18, root 32, etc. So, A1 is equal to root 2, A2 is equal to root 8. You can write this in terms of root 2. So, you can split like this, 4 into 2, which you can write as root 4 into root 2. So, it is 2 root 2. A3 is equal to root 18, which you can write as root of 9 into 2. So, 3 root 2. Similarly, A4 is equal to 4 root 2. Then you have to check whether this forms an AP or not. So, A2 minus A1 is equal to 2 root 2 minus root 2, which is equal to root 2. Then A3 minus A2, which is equal to 3 root 2 minus 2 root 2, which is again equal to root 2. Then A4 minus A3 is equal to 4 root 2 minus 3 root 2, which is equal to root 2. Therefore, what we can write is A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3. So, the conclusion is it is an AP. If this is an AP, you have to find the next one. That means next 3 terms. A5 is equal to A4 plus D. A4 is 4 root 2. A4 4 root 2 plus D is root 2. So, 5 root 2. Similarly, A6 is equal to 6 root 2 and A7 is equal to 7 root 2. So, we got A4 minus A3 is equal to A3 minus A2 is equal to A2 minus A1 is equal to D, that is equal to root 2. So, it is an AP, and A5 is A4 plus D, which is equal to 5 root 2. Similarly, A6 is equal to 6 root 2 and A7 is equal to 7 root 2. Next, 15th question. It is given that the series is given as 1 square, 5 square, 7 square, 73, etc. So, the first one is 1 square, which you can write as 1. A1, A2 is equal to 5 square, which is equal to 25. A3 is equal to 7 square, which is equal to 49. A4 is equal to 73. You have to check whether this form an AP or not. So, A2 minus A1. A2 is 25 minus 1 is equal to 24. A3 minus A2 is equal to 49 minus 25, it is again equal to 24. And A4 minus A3. A4 minus A3 is equal to 73 minus 49, which is again is equal to 24. So, what we can say is A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3, which is equal to 24. So, clearly D is equal to 24. Then find next 3 terms. So, A5 is equal to A4 plus 24. A4 is 73. 73 plus 24. So, 97. A6 is equal to 97 plus 24, which is equal to 121. A7 is equal to 121 plus 24, which is equal to 145. So the next three terms are 97, 121 and 145. Then homework. Exercise 5.1, first question, second question, second and fourth subdivision, third question, second and fourth question, second, third, fourth, sixth, 7, 8, 9, 10 subdivisions.